All right, hello. Apologies for the pretty long delay there. I've had some technical difficulties getting set up here. Can everybody hear me? Yay, nay? Yes. Awesome. All right. Yeah, awesome. So, I will give a quick warning here. It is a bit windy, and that is probably going to completely ruin half of what we're going to try to look at tonight. So I apologize if that makes any images through a telescope or a camera appear kind of shaky, or in general that will make everything look a bit fuzzy. So we won't have any super crisp and sharp images, but we end up often facing that here anyway, so that's okay. So, hello, my name is Ben West. I am the assistant here at the Edinburgh Planetarium in Glassboro, New Jersey, or at the Rowan University. And so I will be doing the open house here tonight, remotely from our roof, or not remotely in my case, but from the roof of Science Hall here on the campus of Rowan University. So I see a ton of people here. That is awesome. So, I'm going to go ahead and switch us on over to a view through our telescope right now, which, assuming it hasn't drifted too much, is currently set on the moon here. So we are currently looking at a view of, not a properly flipped view of our, there we go, that's right. We're currently looking at a view of our moon here, in part because I was pointing us there to test the telescope, but also because it looks pretty nice tonight. So right now we are looking at the first quarter phase moon, which is to say that the new moon phase, when the moon is not quite, but roughly between the sun and the Earth. When it's exactly between, we have a solar eclipse. We did not have a solar eclipse, so it was just a standard new moon. But new moon was about 1 month ago. Sorry, 1 week ago, my bad. And so now that we are about 1 week past new moon, we are in the first quarter phase moon. So the moon has gone about 1/4 of the way around the Earth. And as a result, we're currently seeing half of it lit up. In another week, we'll go into the full moon phase when it will be fully lit up. In 1 more week past that, we'll be into the third quarter phase when the other half of the moon that we see here is lit up. And then in 1 more week after that, we'll be back in our new moon phase. So looking at the first quarter phase here, where the kind of right half of the moon here is lit up, there's a lot of pretty cool stuff that we can see. And so if you're looking at the moon here, you can see a lot of craters along its surface. You can see craters over here or over there. For instance, just a lot of cratering in this section over there, which is toward the southern part of the moon, as well as some other features down there, and some darker patches, which I'll get to momentarily. So all of these circular things here, all these circular features, are craters, or areas where chunks of stuff from space have hit the moon and knocked off a chunk of the surface of the moon there, and left behind this nice feature for us to look at. And what's pretty neat about these craters is that they're not a flat thing on the surface. They have depth, and there's a crater rim here, the ridge of this crater there, which is a bit higher than stuff inside of the crater itself. And so we can see shadows being cast over the crater rim here, because this area of the moon basically is in morning right there. That's right where there's a sunrise, or over here kind of, in a sense, early morning. And so we're seeing shadows being cast over those craters. And the closer and closer you get to this kind of dark line there, which is called the terminator, which is nothing to do with the movie The Terminator, but everything to do with just the dividing line between day and night on the moon here, or on any object. The closer you get to the terminator, the deeper and deeper these shadows get, or conversely, the further away you get, the shallower they get. So when we're looking at some of the craters over here, there are very, very, very thin shadows, whereas over here, they're very, very, very deep shadows. And so if you wanted to apply some geometry there, you could actually use the depth of those shadows to figure out how far away the moon is from us. And people actually did that quite a long time ago. But anyway, so as I mentioned, the dividing line here that we're seeing is the dividing line between day and night, looking at the moon. So this is the daytime side of the moon, and over here is the nighttime side of the moon. So this is the side currently facing toward the sun, and this is the side currently facing away from the sun. Something pretty fun, which I'm not quite sure if we can see. I'll see if I can increase our exposure a whole lot here. Is if we... Is that going to work? Not quite. Actually, a little bit here. So we're looking, I've overexposed our image of the moon, but for a very good reason. So as I mentioned, here is the daytime side of the moon, the side currently facing toward the sun, and this is the nighttime side. And you might notice now that I've cranked up the exposure on the camera that you can actually still see, very, very hard to tell, but faint circular feature there. You can see that the full moon, or the entirety of the moon, is still visible there. We just have a darker area and a brighter area. So in much the same way that the Earth gets lit up at night... Oh, I'm sorry, there's supposed to be, someone is mentioning to me that they can't see any arrows. It's supposed to be capturing my, my cursor. I apologize. Normally it does. Give me 1 second here, I'll see if I can fix this. Ah, the capture cursor thing was not selected. That's super helpful. As I mentioned, technical difficulties. So this is the Terminator. Can you all see my cursor now when I'm doing that? Yes, okay. Thank you. I apologize for that. I didn't think to check to see if my cursor was visible. So, give me 1 sec here. Alright, Nick Damon in Zoom, could you please set me as host? I'm not entirely sure. There were some technical difficulties at the beginning. I had my internet connection drop, and I think somehow someone else got set as the host here in Zoom, just to prevent any problems here. Anyway, so as I was trying to say, I apologize, you can see very faintly a circular outline to the moon. And so I've overexposed our camera view here. And what we're actually looking at is, you can still see a little bit of the moon. This side of the moon is being lit up by the Earth in exactly the same way as the moon lights up the Earth at night. So whereas we can see moonshine here on the Earth, you can very faintly here see Earthshine on the moon. So this side of the moon here that is facing toward the Earth, but is currently not able to see the sun, it's currently in nighttime, is still lit up a bit by light being reflected off of the Earth. And so if you have enough patience to do some photography here, you can capture both the bright side in one picture and the dark side in another picture, and actually get a composite picture where you can see both the slightly darker side of the moon, or sorry, the significantly brighter side and the somewhat darker side of the moon here, but both sides facing toward us. And so there is also, of course, another part of the moon which is not facing toward the Earth or toward the sun, that is incredibly dark, that's not getting light from either of us. And so there are basically three different brightnesses of areas on the surface of the moon right now, if you were to go all the way around it. All right. So I mentioned the darker patches, and I said I would get to that. So the darker regions we see here on the surface of the moon are known as maria, which is Latin for seas or lakes. So the maria, early observers of the moon, were looking at the moon and thought these looked kind of like lakes on the surface of the moon. And we hadn't gone there. We didn't have telescopes, so we couldn't see the moon in very great detail. If you look at the moon with just your eyes, it's kind of hard to tell a whole lot of specific feature, to see a whole lot of specific stuff on it. And so And so they weren't quite sure what these features were, but now we know that these are actually volcanic plains. So the lunar maria formed when things hit the moon and created craters, which is why these are circular. And these craters filled up with lava with magma from beneath the surface. And as that magma or lava cooled, we ended up getting these very, 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 very smooth volcanic plains. And so they are incredibly smooth, which also makes them rather nice for, say, landing a spacecraft on. And so these were, for the most part, the sites where the Apollo, the lunar missions, landed on the moon, because they are relatively far smoother than other areas of the moon. I mean, you can pretty easily see that here. This, even through the telescope, looks rather smooth compared to, say, the very cratered region over there, which doesn't have these maria. And you can see that there's some other areas with maria that are currently right along the terminator, although there are also craters that have been created within these maria. So over time, you can have something hit the moon where something else had already hit the moon. In other words, you can have a crater form within another crater. So we have all these craters here that have formed within this larger crater. And if you're looking around here, you can also see other instances where there are overlapping craters. Something else we can also see is if you look really carefully around, say, this crater there or this crater over here, you'll notice a little bit of stuff right at the center. And that is actually material which kind of bounced up during or shortly after the collision with the moon, sort of like a ripple on water. So you can have material bounce up in the center of a crater. So I'm going to get to a couple of questions I saw here in the chat. Someone asked, what is the aperture of the telescope? The aperture of the telescope I'm currently using is 6 inches wide. Now you can use far, not as I can't think of the right word. I don't know why. You can use less wide telescopes and see a whole lot in the sky. The wider the telescope you get, the more light you can collect, and that can help you to see dimmer things in the sky a bit easier. It can also help you get a sharper image, but it can have some other drawbacks. A larger telescope can have a narrower field of view, that is to say, kind of a higher amount of zoom. If we're trying to look at a large object in the sky, like the moon here, if I use a larger telescope, we might not be able to see as much of the moon. At the same time, though, that can also be pretty handy for some other things. It really depends on what you want to look at in the sky. So what is the field of view of the, well, basically the whole setup that we're currently using to look at the moon. So the moon, very, very, very conveniently, is about ½ a degree wide in the sky. So if you were to imagine drawing a big circle around the sky and slice it up into degrees, 360 degrees in a circle, take one of those degrees, split it in two, you get about the width of the moon. So the moon is just about 1/2 of a degree wide in the sky. And so if we can just about fit the whole moon, not quite, but just about fit the whole moon in our view here, at least vertically, so looking, top to bottom here, we can almost fit the entirety of the moon. Our field of view, at least in the vertical axis here, is about ½ a degree. It's a little bit wider than that when we're talking horizontally, but we're roughly ½ a degree, give or take, field of view with our current optical setup. It's a mixture of the camera, it's a mixture of the telescope, it's a mixture of a couple things. And another question there, what is the optical design of the telescope? We're currently using a Schmidt-Cassegrain telescope, which is a reflector telescope that works by having a... oh man, I'm on the roof and there's some loud machinery. I hope it's not kind of getting ruining the microphone here a bit. It is a Schmidt-Cassegrain telescope, which is a reflector telescope. So we have light coming in one end of the telescope. It bounces off a mirror all the way at the back end of the telescope, which goes up to another secondary mirror, and then bounces down to the camera. Can't hear the machines. All right, hopefully that's just, I think Zoom is doing its noise cancellation. I'm not sure what's going to happen in YouTube here. But cool. All right, let's see. Did I see any other questions? I apologize to some of the people who might have gotten removed at the very beginning. I see a couple people mention that. I think that was because of a mix-up in who was the host, which I'm not entirely certain how that happened again, but that's okay. That is fixed now. So, all right, I am going to move us off of the moon here to a nearby object in the sky. And so, let's move just a little bit. Now, the object I'm going to point us to is going to look incredibly lame through the telescope for a whole bunch of reasons. One of them being that the telescope's apparently not pointed right. There we go. So if you see this orangish reddish thing that is for some reason moving very quickly through a view, I think the telescope's it's just windy. If you can see this orangish reddish dot, which can't quite zoom in on here, that orangish reddish dot is actually the planet Mars. And so you can actually find Mars tonight, not too far away from the moon. If you were to walk outside right now, oh no, it is kind of a distance. If you were to walk outside right now, I can actually, I have another camera I could point in that general direction. Let's see if I can get that pointed quickly. I see someone who has said, wow, is that the sun? That is not the sun, that is the planet Mars. So, well, we're getting this going here. There is something pretty cool that happened on Mars just the other day, just yesterday. Did anybody hear the recent news that happened on Mars? There was something pretty cool. Yeah, Ingenuity. So, the Ingenuity is a helicopter, and it is part of the Perseverance mission. So the Perseverance rover landed on Mars about a couple months or so ago, and so Perseverance is a rover, much like some other rovers we've had on Mars before. So it's basically like a gigantic car that we land on the surface of a planet or another object, in this case Mars. I say another object because we've also landed rovers on the moon. But so it lands on Mars, and it has scientific instruments so that scientists back here on Earth can remotely study that planet without having to actually go there. And Perseverance brought with it the Ingenuity helicopter, which is a kind of like a drone that you might be able to buy at the store here on Earth. Except that, well, it's a helicopter with two rotary blades on it. And those blades are rather long compared to what you might find here on Earth, and also have to spin incredibly quickly. I believe it's somewhere around 2,500 frames per second, which is crazy. And so the reason why it has to spin so quickly, or why they have to spin so quickly, rather, there are two that spin in opposite directions, is because the air on Mars is incredibly, incredibly thin. So the air on Mars has a thickness of about 0.6%, 6 thousandths that of the air here on Earth at sea level. And so because it's incredibly thin, you have to spin a rotor or move some kind of a wing far quicker through Mars's atmosphere in order to get any kind of significant lift. And to help with that, you can also make a far longer, far wider, just generally larger wing. So the blades on the Ingenuity helicopter are quite large. But anyway, the Ingenuity helicopter just recently did its first test flight yesterday, where it lifted off the surface of Mars and then went back down. So it didn't move around, it didn't fly around the surface of Mars a whole lot. It pretty much just went up and down. But that is the first flight of another aircraft on another planet. So it's kind of like the Wright brothers moment, which is really, really, really awesome. So just someone asking to confirm here, the dark patches on the moon are referred to Maria. Yeah, they're referred to as Maria. So the darker features are the Maria, and then you also have the lighter, just general surface of the moon. So I'm trying to get a camera here set up, pointing it in this general direction, so we can try to... Oh boy, that looks horrible. The wind is not doing me any favors. At all. Oh boy. Yeah, that is not going to do. Oh no, that'll do alright. Cool. So, I'm going to switch our view here over to a secondary camera, which is currently flipped the wrong way. Let's flip that back. Alright, so we have our secondary camera view here. And what we're currently looking at are, we have the moon up here, which is rather bright, so pretty overexposed in our image. And we also have a number of stars and clouds that are completely ruining the lower parts of the image. So what we're actually looking at here is, right over there we have the constellation of Gemini the twins, of Castor and Pollux. Castor actually being a pretty awesome star because it has a total of 6 stars within it. Although you can't see them all through a telescope, although we should be able to see 2. We should be able to see a couple as a binary appearing star, so 2 stars really, really close together. But I believe Mars might be slightly obscured, or not quite. No, I believe that actually should be Mars right over there. So we should be seeing Mars right there as that dot that was almost blocked by the clouds tonight in the sky. So if you see the moon over here, you can see Castor and Pollux, and then kind of going roughly in that direction down here, we can find Mars tonight. I would point out some other another couple constellations which we could use to find it, but unfortunately the clouds are not cooperating. There aren't a whole lot of clouds. There are like no clouds in the sky except in that direction, which is just lovely. But someone has asked here, why does the wind affect the light transference from the Mars image? Why does wind affect how light is getting to us here? So wind is going to... What wind is it's moving air, right? And as that air moves, it will... The turbulence of the air can slightly muck with the path of light. Part of that can be due to different temperatures. I believe that would be the slightly different temperatures in the air moving. But my mind is drawing a blank on some things there, but that's okay. Something else that's going to muck with our view of Mars there because of the wind is actually not the air being moved at all. Well, that is part of it, but also that the wind is shaking our telescope, which is not all that great. If we want a nice picture, we want a very stable telescope. If we have a shaky telescope, we're not going to get a very nice picture. So if you're watching it here, it is shaking around a lot. And that means that we can't get the light coming from Mars to focus down to a single point that's not moving on the surface of our camera, which means we can't get a sharp, crisp image. But as you have air moving through the atmosphere, all the way from the upper reaches of the atmosphere, the last bit of air before you reach space, starting there all the way down to where we are here on the surface of the Earth, a number of kilometers of air that is 100 or 80 or a number, depending on who you ask, of kilometers there, or several, 80 to 50 or so miles of air, again, depending on who you ask, for what really counts as outer space. As light travels through all of that air, with different temperatures of air, with different movement of air, you're going to have slight deflections of that light, ever so slight, and that adds up to end up with a blurrier and blurrier and blurrier image. And astronomers call this blurring of the image seeing, which is a super confusing name that I'm sure has not led a single person astray in their understanding of some astronomical terms. But seeing is a description of how good your view of stuff up in the sky is on some night, bearing in mind turbulence of air and all sorts of other things that can affect how you're seeing that light. So someone has asked how Percy, meaning the Perseverance rover, can send signals back to Earth so quickly. It really depends on what you mean by quickly. So there is a significant delay between Earth and Mars, because Mars is located rather far away from us. And currently, let's see what this delay is right now. It changes depending on where we are in with respect to each other, so where we are in our orbits. Currently, the delay to Mars is 16 minutes and 7¼ seconds, give or take. So it takes about 16 minutes for any light we send from Earth to reach Mars, and any light sent from Mars to reach Earth. And that also includes things like radio. So any radio signals we send, radio is a color of light, basically, and so it travels at the speed of light. And any radio signals that we send from Earth will take about 16 minutes right now to travel from Earth to Mars, or from Mars to the Earth. And so if we're sending a signal from the Perseverance rover, it's going to take, in that case, that's about 1/4 hour to reach us. Which also means if something were to happen, it sends us a signal, takes about 16 minutes to get to us, and then we take about 16 minutes to reply, plus any time it takes us to actually figure out what to reply with. If something happened to it, we wouldn't be able to issue any commands to fix something for at least about a half hour. So there are significant delays to things, transmissions between planets, in this case between the Earth and Mars. But in the grand scheme of things, 15 minutes, 16 minutes, what have you, isn't all that bad, right? Earlier on in, say, even like in our country's history, where people would have to communicate with England, you know, you'd have to wait several days or weeks or months sometimes to get a message across the sea. 60 minutes, that is not that bad in the grand scheme of things, right? But that can be a world of difference for something that's moving on another planet. So anyway, I believe we've been on Mars here for a bit long. So I am a slightly different patch of the sky, except that there are clouds covering up a whole lot of the nice stuff in the part of the sky I was just going to point to. I will improvise a different plan. So we have clouds in one part of the sky, and in the other part of the sky, Rowan University has a field lights on for a soccer field, I believe, which is lighting up the other part of the sky over there that I can see, which makes sure not everybody else wants to look at what looks like just an orange dot here all night long. I apologize. So I have switched this over to a different patch of the sky, and my camera is not cooperating. This is a night fraught with technical difficulties. I do apologize. All right. So I'm going to switch this over to, I have a camera now pointed toward the Big Dipper, and Big and Little Dippers, which are partially obscured by a cloud, apparently, that I can't quite see with just my eyes because it's rather faint. But I will just point out while I get some other things going here. Looking at the Big Dipper here, if you take these two stars in the Dipper, you can follow them out in a straight line, and you come upon the North Star Polaris right down there, which is the last star in the handle of the Little Dipper, which you can very faintly see as very faint, very hard to see star down here, and two other stars there. So we have the Little Dipper there, as well as the Big Dipper up here. And I am mostly using this as a delay so I can point our main telescope to the wind. Right in the handle, the kind of star right in the middle, you might notice actually appears to have two stars there. So this star is known as Mizar Alcor. And Mizar and Alcor make up something known as a double star, where we have two stars high, although not physically close together in space. So these are two star systems, actually. I'll get to that in a second, which just happen to line up very close together from our perspective here on Earth. You can't see any stars. You should be able to see some stars. It looks like kind of streaks because of the wind. So the wind has messed up the view of the camera a little bit. So if the wind hadn't messed up the view of the camera, we'd actually be able to see that Mizar here is actually appears to be a binary star, where we see two stars very, very, very close together that are in fact actually orbiting around each other, so make up a star system. Each of the two stars we'd see there, if not for the each of the two stars that we'd see are themselves actually two stars. So the brighter Mizar here is actually four stars really, really, really close together. And Alcor is two stars really, really, really close together. And I was hoping to show with its multiple stars, although we'd only really be able to see two distinctly. But unfortunately, it seems that the seeing is just bad enough that they blur together into what looks like a tiny little line. But I can show at least where it is here. So that is Castor. It would look a lot nicer if not for the shakiness and blurriness caused by some of our weather today, which is unfortunate. So if we are looking at the Big Dipper, I'm going to, that makes a lot of sense. There we go. That should fix that. All right. Let's see if we can get this in frame. All right. So, if you take, the clouds have moved over there too. Shoot. Right now over here we have the handle of the Big Dipper, and hopefully, I've just taken this one picture, hopefully the clouds will allow us to see some stuff later on, but we might end up having to call it, because we're starting to get a whole bunch of very, very thin but still annoying clouds popping out. But if you take the three stars in the handle of the Big Dipper, which I've put right over there, we can actually follow them, and you can arc Arcturus. And Arcturus is the brightest star in a constellation called Boötes. Boötes is supposed to represent here a herdsman in the night sky. So it's supposed to be a person, although it's a little bit hard to tell this constellation as a person. So you kind of have to turn your head to the side here. You could see the kind of torso and body of Boötes, which looks almost like an ice cream cone or maybe a kite. And so you have the torso or body of Boötes here, and you can also see the legs of Boötes very faintly, although the field lights and the clouds are both cooperating together, kind of conspiring together. Actually, it might be worse. Never mind. They're conspiring together to make that view a little bit hard to see. But our Mizar and Alcor. Let's see. Oh, they're actually, the two star systems are very close together. Incredibly close together. They are close enough together that it is not entirely certain if they are related or passing by each other, or so they could potentially be orbiting around each other, which would make it a system of 6 stars. They could be 2 star systems passing by each other. That is up in the air, so to speak. Well, not in the air, but higher up in the air, but you know what I mean. So that's actually pretty interesting. So yeah, 0.27 light years apart. So 1 light year is how far you travel going at the speed of light for 1 year. Light travels at about 300,000 kilometers per second, or 200,000 miles per second. So about a quarter of a light year, or specifically I would point the telescope there, but we actually can't see that patch of the sky from the northern hemisphere of the Earth where we live, or where I live here at least. But anyway, so Proxima Centauri is orbiting Alpha and Beta Centauri at a distance of about 0.2 light years, so that's not too far away for things to orbit. But I believe we're still rather sure that they are separated enough to. But apparently that is a matter of debate. They do appear to move generally together, although they are many of the stars in Ursa Major, the constellation the Big Dipper is a part of, move together through our galaxy. So, that was a really great question. Someone else's telescope. Everything we're seeing through the telescope right now is a part of the Milky Way. But because we're all within it, every star we're seeing in the night sky, the moon, all of this is part of the Milky Way. But I assume you mean the fuzzy part of the sky that is the Milky Way that we see as the distinct galaxy itself, as opposed to or rather as the general galaxy itself, as opposed to all the distinct stars. So you don't really need a telescope to see the Milky Way. What you need to do is you need to go out somewhere far enough away from people, not where I am right now. But if you get far enough away from people where it's rather dark and you should be able to see some very, very, very faint things in the sky, you should see across the sky. Part of that also depends on what time of year you're out looking. Let's see. But at other times of the year, it will arch all the way across the sky. If you wait a few months, then shortly after sunset, it will be arching all the way across the sky. That would be a good time for that would be about, say, July-ish, late July, or, well, just July in general, I guess. But you don't need a telescope to see the Milky Way. In fact, the telescope would be great for seeing specific objects scattered throughout the Milky Way, but for seeing the band of the Milky Way itself, you actually would want to do that more so with just your eyes, without a telescope. So, I think the clouds are as well as some of the bright lights obscuring another part of the sky. But there is a star cluster which we might be able to see in another part of the sky here. So I will move our telescope over to that. It is getting a bit there's some very thin clouds, even though it should have been clear tonight, and that is enough to unfortunately ruin our view of some of the things in the night sky. So I apologize for that. But to answer a couple questions here, from the northern hemisphere of the sky, is it the same from the southern hemisphere? I guess the moon would appear upside down, but yeah, that would all be the same. Although I believe your view of the moon itself would appear kind of flipped a bit. Well, it depends on where you are in the southern hemisphere, I guess. But But yeah, so I apologize. There are very thin clouds covering up a lot of the other stuff. So I'm going to go ahead and call this. But thank you for joining us here for our, unfortunately, slightly fraught with technical difficulties and other difficulties, night of observing from the roof of the Edelman, sorry, not quite at the Edelman Planetarium here, but of the getting within of Science Hall on the campus of Rowan University. So once again, thank you. Apologies for the somewhat abrupt open house here. Often the weather does not cooperate when astronomers would like to do things in the night sky, and it seems other bits of technology